Hello everyone, I'm Aicha Idoum, PhD student and member of Thermodynamics and Energetics Laboratory, Faculty of Science of Agadir. I'm very pleased to be here with you today to present one of the studies that will make a huge contribution to the field of energy efficiency in construction and building materials. My presentation is entitled Recycling of Agricultural Waste as Additive for Red Bricks. The building sector is considered one of the most energy-intensive sectors in the world. In this sense, scientific research seeks to propose solutions for an energy transition toward renewable and ecological resources. The objective of this study is to use locally available natural, recyclable and environmentally friendly materials as components of building materials in order to improve the comfort of the building environment. The use of natural material does not only meet the requirements of the thermal regulations in building by reducing energy consumption, but also meets the challenge of sustainable development. In the present study, new composites based on local material are evaluated experimentally in order to obtain environmentally friendly materials with low manufacturing costs and the best thermophysical properties. They are mainly fired clay bricks, incorporating biomass waste additives. In our first phase, I present you the materials and additives chosen to make the samples. The criterion for the choice of material is mainly the local availability. The red clay is presented as a material with high thermal performance. Unlike most building materials, clay can be used in its natural state. The clay was extracted from a red clay quarry. The powder of biomass additive used is obtained by grinding using a knife mill, then sieved. We have made the brick samples by varying the percentage of additives and red clay. Samples with 0% biomass additive were made to compare the impact of the biomass additives incorporated in the bricks. The bricks were baked in an electrical oven up to 1050 degrees C. We will focus today on presenting thermophysical results of the samples and comparing 0, 50 and 20% of biomass additives. The bulk density and the porosity percentage of the samples are measured according to standards. The thermal conductivity was determined using a hard disk PES22 analyzer. The physical properties of the sample's composite show that incorporating biomass additives in fired clay bricks reduces the bulk density to 42% and decreases the porosity by 32% using 20% of biomass additive. The thermal conductivity of the bricks is presented in the figure. The results show that the bricks with biomass additive reach a conductivity of 0.27. The thermal conductivity is reduced by 53% using 20% of biomass additive. The decrease of the thermal conductivity is associated to the formation of pores. In fact, the thermal conductivity decreases because of the low thermal conductivity of air in the newly formed pores. The aim of this study is to use locally available materials as building materials in order to improve the energy efficiency in buildings by reducing thermal conductivity and improving physical properties such as bulk density. To analyze the impact of the percentage of biomass additives on the properties of bricks, we added 50 and 20% of biomass to the mixture of red clay. The clay samples showed that the thermal conductivity decreases with the increase in the percentage of additives, and this is due mainly to the formation of air pores in the bricks. The use of composite, clay and organic additives can revolutionize the building industry by allowing significant saving. Thank you, and welcome to your questions and comments.